Hello students, welcome to class 12 physics. In this video we are going to solve numericals of the textbook of chapter 6 electromagnetic induction. Numerical number 8. Current in a circuit falls from 5 ampere to 0.0 ampere in 0.1 second. So here there is change in the current, that is from 5 ampere to 0.0 ampere. That is final current minus the initial current, that is equals to minus 5, and the change in the current is in time interval 0.1 second. If an average EMF of 200 volt induced, that is average EMF E equals to 200 volt. Give an estimate of the self-inductance of the circuit. Here we need to find L. So we know this equation for the self-induced EMF, that is E equals to epsilon equals to minus L delta I by delta T. Here taking L as the subject, we get minus L equals to 200 upon delta I by delta T. Here delta I by delta T, that is 0 minus 5 upon 0.1, that is minus 5 upon 0.1. Induced EMF, that is 200. So when we solve this we get 4 Henry. So the self-inductance of the circuit, that is equals to 4 Henry. So students, you may copy down this numerical. Now numerical number 9. A pair of adjacent coils has a mutual inductance of 1.5 Henry. So here M equals to 1.5 Henry. If the current in one coil changes from 0 to 20 ampere, that is the change in the current is 0 to 20 ampere, that is 20 minus 0, that is equals to 20 ampere in 0.5 second, that is in the time interval 0.5 second. Delta T equals to 0.5 second. What is the change of flux linkage with the other coil? So here we are talking about the one coil, and for the other coil we need to find the change in the flux. So from the equation of the induced EMF we get epsilon 2 equals to minus d phi 2 upon dt, which is equals to minus m di by dt, because here epsilon 2, that is induced EMF, we can write it as minus m di by dt, di1 by dt. So when you compare these two equations, minus minus gets cancelled and dt gets cancelled. So what we have is d phi 2 equals to m di1, that is delta phi 2. We can write that in terms of the delta. So delta phi 2 equals to m delta I1. Delta phi 2 equals to, put the value of the mutual inductance, that is 1.5, and delta I1, that is 20. So when you calculate this we get 30 Weber. So the change in the flux linkage in the other coil, that is 30 Weber. So student, you may copy down this numerical. Now numerical number 10. A jet plane is traveling towards west at a speed of 1800 km per hour. So considering the direction, jet plane is traveling in the westward direction and its speed is, that is v equals to 1800 km per hour. Converting that into meter per second, we get 1800 into 1000 upon 3600 meter per second. This gets cancelled, so we will be having by 2, this becomes 50 into 10, that is 500. So V equals to 500 meter per second. What is the voltage difference developed between the ends of the wing having a span of 25 meter? That is, the distance between, or the length between the two wings, is 25 meter. If the Earth's magnetic field at the location has a magnitude of 5 into 10 raised to minus 4 Tesla, 5 into 10 raised to minus 4 Tesla, and the deep angle, that is theta, equals to 30 degree, we need to find the potential difference, that is the EMF. So here, as said, the north, south, west, east jet plane is moving along this direction. That means here will be the wings. The length of this wing will be 25 meter. Here it is considered as L. Jet plane is moving in the west direction, so velocity will be in that direction. So now, taking the vertical component of the magnetic field, here the component of the magnetic field of Earth which is perpendicular to both the velocity and the length in the vertical component is the vertical component BB. So here, taking BB is equals to B sine phi. Here magnetic field is given as 5 into 10 raised to minus 4, and deep angle, that is given as 30 degree. So sine 30 degree. So 2.5 into 10 raised to minus 4 Tesla. Now induced EMF across the length L of the wing of a plane, that is BV into V into L. Now we know that the value of this BV, that is 2.5 into 10 raised to minus 4, velocity, that is 500 meter per second, and length is 25. So when we solve this, we get 3.125 volt. So student, you may copy down this numerical.